Okay, we're now going to look at how we can sort on properties other than the one that we maybe consider gives the natural ordering. So just as a recap, we've got our t-shirt class. A t-shirt has a colour, a size and a price. And if we were to sort it, we've implemented the compared to method such that it will sort it based on size. So we're saying sort of the default ordering for t-shirts, if we have to sort them, is on size. But let's say this is on a website and we also want to give the users the opportunity to sort by price. We obviously can't implement the compare to method more than once. So what we have to do instead is to create a comparator that determines a particular type of sorting for a particular thing. So to do that, we can just add a new class. So we can say new Java class. Typically, we probably want to say what it's going to compare. So let's say in this case, we're going to compare the price of the t-shirt. We might say price comparator. Okay. And we want to implement a method called comparator. Okay. And a bit like comparable, it's a generic type, and therefore we want to specify that it's a comparator for a t-shirt. Okay, so we want to say t-shirt. Okay, and the type that goes in here is the type that we would implement the compare method for. Okay, so if we click on implement methods, it's telling us we've got to implement compare. Okay, now you'll actually see that this interface has a lot of methods in it, but the only one that doesn't have a default implementation, i.e. the only one that we actually need to do anything about, is the compare method. So I'm just going to leave that one selected and click on OK. So this allows us to compare one t-shirt with another t-shirt, okay? And they're called O1 and O2, a bit like we had O for other, okay? We could call it t-shirt 1 or t-shirt 2. I think we're okay with leaving it at O1 and O2 because this is going to be the only method in this class, so it's not going to be difficult to understand what O1 and O2 are. And all we do is compare in the same way that we compared when we implemented the comparator. So if we remember, if we want something to come before another thing, so if we want O1 to come before O2, we return a negative value. If we want them equal, we say 0. And if we want O1 to come after O2, we implement positive. Okay. So we'll go back to our price comparator. And actually, really, the way to do that is just to say O1 minus, or O1.price, get price, minus O2.get price. It's worth noting that we don't have access to the private variables when we're implementing comparator. So yeah, we have to have a property for getting the value. Okay, so once we've done that, we now need to use the comparator as a parameter for the sort method. So if we go back to our main class, before we were just sorting collections of t-shirts and it used the default. You know, this uses default or natural or ordering, okay, which is, in this case, we've determined that to be the size, okay. But if I want to, we'll comment that one out for now. If I want to sort it using by price, I need to create an instance of the price comparator. So I can say price comparator equals new price comparator. It gets me a new price comparator. And then I just say collections.sort. I pass in the list, which is my t-shirts. And I pass in the comparator, which I've called price comparator. So now if I run my code, I think we obviously can see the last example. Let's just comment that out for now. We'll sort it by size first of all, so you can see that the size one is working. So we go large, medium and small. I think it's because we swapped the order around, isn't it? Yeah, we did. So if we put this back the other way, small, medium and large. If we go back and run that again, there we go. So it's not in price order, but if instead I use the price comparator, we'll get the items in price order. Okay, we could repeat this. So for example, we might decide that there is a color comparator. So let's just do that. So we'll say, oops, we'll say new Java class color comparator implements comparator for a t-shirt. Okay, and then when we implement the compare method, sorry, you can see it's a t-shirt. Just to sort of reiterate that, if we don't put the t-shirt here and we implement this, it's going to say object 1 or object 2, but that won't give us access to the properties of t-shirt. So we want to change that to a color comparator for a color comparator that implements a comparator for t-shirt. Okay, and then these need to be t-shirt and t-shirt. Okay, so these types have to match that type there. Okay, and then we could say, well, we'll just return colors by alphabetical order. So we'll return t-shirt 1 dot get color dot compare to t-shirt 2 dot get color. Okay, and then if we go back and change the sort here to use our color comparator, so we could say color comparator color comparator equals new color comparator collections dot sort, pass in the list of t-shirts, and the color comparator. And if we sort that, we should get an alphabetical order. There we go, brown, green, and red. So we've implemented interfaces today. Just a sort of recap of what an interface does, it allows us to say that something's got to meet certain criteria, but doesn't say exactly what it must be. Okay. Now, a good example of that in Java is something called list. And you'll notice here that I've got an array list of t-shirts. Okay, but an array list is just a type of list. There are other lists which are still lists of things, but the way that the internal implementation of how those lists are stored in memory works is different. Okay, but they all meet the requirement for being able to look at the things one after the other, to be able to insert things, remove things. So we can actually say we don't care whether or not it's an array list or a list. We just one of the other lists is linked list. So we could have done. So what I could say is linked list equals new linked list, and we could import linked list. Okay, and it will work the same because the aspects of linked list that we use are also available in the array list. So actually, we don't really care what type of list it is, and instead we could say, well, we'll use the list interface. Okay, and if I have a look at that, in fact, it might be an abstract class. Let's have a quick look. Oh, it is a list. There we go. So basically, we know that a list has to have a size. It has to be able to determine whether it's empty. It has to be able to know if it contains something. We have to be able to have an iterator to use on it. We have to be able to convert it to an array, so on and so forth. They're all things that apply to anything that is a list. Okay, but the important thing is what type of list, whether we use a linked list or whether we use an array list, doesn't really matter. I mean, it does matter when you've got large data sets because how quick they are at doing certain things is different. But the important thing is we can use something declared as something that matches that interface, and we can still use sort, because sort will sort anything that is a list. And it doesn't matter exactly what type of list it is. We have to say here what type it is, because we can't create a non-specific type of list. We've got to be able to do all the workings for it. Okay, but it's treated as a list. Okay, and later on we could replace t-shirts, for example, with an array list, as long as it's some kind of list. Okay, as an example, we could say t-shirts equals new array list. Okay, and that's still fine. Okay, because it's a list. Doesn't matter what type of list it is, as long as it meets the requirements of being a list.